Okay, just finishing up this problem. We were in a mad rush at the end trying to squeeze in this video. With Surface 2, my apologies. Surface 2, of course, is this base down below. So, what you're really asked to do, I just wanted to talk about this a little bit more calmly. As you're working out the, surface integral of z ds, you would know that because z is equal to 0, you can substitute that directly in, and that's your surface down below. It is z equals 0. It will be applied to the function that we're evaluating along the surface as well. And regardless of how you break up ds, by the way, you definitely could, if you wanted to, go back to this other definition and work it out in a lot more detail. But the silly thing about that is you would be working out that function approach. You know that f is 0 itself, so s sub 2 is 0. So what we do then is just add up S1, S2, and S3. We already had seen that S3 was radical 2 times pi, and we're good to go. Okay, so just finishing up the very bottom of the notes, there's no problem to work out in specifics, but we do want to at least talk about the normal vector. The normal vector, of course, was this cross product divided by the length of that cross product vector, making it a unit normal vector, of course. Normal vectors always have an understood length of 1. But what we could do then is realize that there are two choices. You could have the opposite of that as well. And these pictures right here are just showcasing that if you have a surface, you could have your normal vectors pointing away from the surface, or they could be pointing inside as well. So something that we need to take a look at is a convention. A positive orientation is where normal vectors point outwards. So let's say we had a sphere. Every normal vector would be pointing away from the sphere. A negative orientation would be where our normal vectors point inward. We'll talk more about that later on. But that's wrapping up surface integrals for today. We are going to pick up and really pour into some vector field applications, something called flux, next time.